Number 57. We're given the mass of the baseball. We are also given the initial velocity of the baseball before it is hit by the batter, and then we're also given the final velocity of the baseball after it's hit by the batter. The equation that we need to use here to find the change in momentum is the change in momentum equals mass times velocity final minus mass times velocity initial. We can plug in our mass and our final velocity, and our mass and our initial velocity, and we can solve for the change in momentum. Next question, they're giving us a time, and they're asking us to find the force. Well, we know that the change in momentum is equal to force times change in time. So we can rearrange this to solve for force. And then we can plug in our numbers. Number 59, they're giving us the mass of a truck. They're giving us the initial and final velocities of that truck as it speeds up. They're giving us the time. They're asking for the change in momentum. Change in momentum is equal to mass times velocity final minus mass times velocity initial. So we can go ahead and find that change in momentum. We know that force times time is equal to the change in momentum. That's the impulse equation. We can rearrange it to solve for force and then plug in our numbers. In this question, we are given the mass of the volleyball. We're given the initial velocity of the volleyball. We're given the final velocity of the volleyball, and the question is, what was the force applied over a given period of time? Well, we know that force times time is equal to the change in momentum. That's the impulse equation. We can rearrange to solve for force by dividing each side by time, and now we can plug in our numbers. In this question, we're given the mass of the brother. I'll abbreviate that M sub B, and the mass of the skateboard, I'll abbreviate that M sub S. We're given the velocity, and we need to find the momentum. Well, momentum is simply the product of mass and velocity. Don't forget to add your two masses together. And there's our momentum. We're given the mass of an object here. We're given the initial velocity, and then parts A and B are asking for two different final velocities to find the impulse. Well, what's our equation for impulse? Remember that impulse is the change in momentum. That's the definition of impulse. So we just need to find the change in momentum here. We know that that's mass times velocity final minus mass times velocity initial. So we can just do that for each of these cases. Here we're given the mass of a baseball, and we're given the initial velocity before it's caught. The first question is to find the change in momentum. We know that change in momentum is equal to mass times velocity final minus mass times velocity initial. The velocity final we're going to use is 0 because you're catching the baseball and it's coming to rest. I chose the velocity towards the towards the catcher as a positive direction, so my change in momentum is going to be negative in this case. For B, we're given the time, and the question is to find the average force. We can rearrange our impulse equation to solve for force and plug in our numbers and we can get our answer. Part C, they're giving us a different time and asking us to again find the force, so I'm going to use the same equation, this time with my different value of time. And there we have it.